Hi again. This is Chem 121, Chapter 1. We're going to do sections 1.3 and 1.4 in this lecture. In sections 1.1 and 1.2, we talked about some of the physical states of matter. In 1.3 and 1.4, we're going to talk about the properties of matter and some changes that can take place in matter. So properties of matter. A property, there are various types of matter are distinguished from each other by something called their properties. Properties are distinguishing characteristics of a substance that are used in their identification and description. So properties of matter are how we tell different types of matter apart from each other. Each substance has a unique set of properties that distinguishes it from all other substances. Properties can be physical properties or chemical properties. And we're going to look at both physical and chemical properties and see how we use them to distinguish one type of substance from another. A physical property is a characteristic that a substance has that we can observe without changing the basic identity of that substance. We can observe a physical property without changing the substance into something else. And you'll see why this is important in the next slide when we talk about what a chemical property is. So a physical property is something like color or odor, something that we can determine basically by just looking at the substance. We can tell the physical state of a substance by just looking at it. We can determine the melting or boiling point of a substance. But when we do that, we don't convert the substance into another substance. When we melt water, when we turn ice into liquid water, we can measure the temperature that happens at. We can determine that melting point, but it's still water. It was solid water, and now it's liquid water, but we haven't created a new, different substance. It was just solid water, and now it's liquid water, and we can measure the temperature where that happens. Similarly, when we boil water, when it goes from liquid water to gaseous water, like we saw right here, we can measure the temperature where this takes place. We haven't converted the water into a new chemical substance when we do this. It's just liquid water or gaseous water. And with a thermometer, we can measure the temperature where this takes place. Boiling point is a physical property because we haven't changed the water into something else. When you list boiling point as a physical property of water, you always have to say the temperature that water boils at. You can't just say boiling point is a physical property of water, because saying boiling point is a physical property doesn't really distinguish water from another substance, because all substances have a boiling point. Saying water boils at 100 degrees will distinguish water from another substance. So when you indicate melting and boiling point, you always want to indicate a temperature. Similarly, when you indicate a physical state, to say that water is a liquid, we'd have to say the temperature that water was a liquid at to distinguish water from another substance. So liquid is a physical state, but to indicate water or liquid as a physical property, you'd want to say the temperature at which water is a liquid. So the important takeaway for physical properties is there characteristics of a substance that can be observed without changing the basic identity of the substance, without changing the substance into something else. And when you list particular physical properties that are based on temperature, you always want to indicate the temperature associated with that physical property, like melting point, boiling point, or physical state. Chemical properties are very different from physical properties. They are characteristics of a substance that describe the way a substance undergoes a change or resists a change. Flammability, combustibility, reactivity, corrosion, or rusting are all examples of chemical properties. But unlike physical properties, chemical properties change the substance that you're talking about into a new and different substance. If we want to determine if methane reacts with oxygen, well, the only way to determine that is to react some methane with oxygen. But once you do that, the methane gets turned into two products, carbon dioxide and water. So to determine if methane reacts with oxygen, you have to react it with oxygen. And now the methane that you were asking the question about has been turned into a new, completely different substance. So unlike a physical property, where we can measure it without changing the substance into something else, the only way to determine a chemical property is to form a completely new and different substance. If you want to know if something is combustible, you have to burn it. But by doing that, you turn that substance into two completely new and different products. Notice the definition of a physical and chemical property both use the word change. It's hard to define physical and chemical properties without talking about how it refers to change. So back here, when we're talking about these properties, we talk about the word change with physical property, and we talk about the word change when we talk about a chemical property. So even though we're talking about property, we're talking about the word change. So let's talk about now a physical change. A physical change is a process where a substance changes its physical appearance, but not its chemical composition. A physical change would be boiling or freezing water. A new substance is never formed as a result of a physical change. Boiling or freezing water, we can observe the physical property of water as either a solid or a liquid or a gas without changing them into something else. So notice here, talking about physical change, we can talk about the physical property of water as a solid, liquid, or gas. So properties and changes, they're linked to each other. The physical change is going from the solid to the liquid to the gas. The property is water either being a solid, liquid, or a gas at a given temperature. But this is all a physical process because at every step of the way, it's still water. Chemical change is very different. A chemical change is where we take two reactants, like methane and oxygen, and turn them into two completely different substances, carbon dioxide and water. A chemical change is a process where the substance undergoes a change in chemical composition. It involves the conversion of the materials into one or more new substances. Notice here, there's no way to observe a chemical property of reactivity except to do the experiment. And once we do the experiment, we change the methane into carbon dioxide and water. So in this section, these two sections, where in section 1.3, we were talking about chemical and physical properties, and in 1.4, we were talking about chemical and physical change. It's really hard to talk about one without talking about the other. Because when we talk about chemical changes, we're looking at the chemical property of reactivity. And then the last part, when we were talking about physical changes, well, we were observing physical properties that changed because of the physical change. So here's a concept check for you. The most helpful way to do concept checks is to read the question, then pause your recording and try to write out some kind of an answer. And it really helps to physically write it down on a piece of paper. It's a very different process to think through the answer in your head as opposed to trying to write something down. So whether we burn alcohol or when we when we boil alcohol or when we burn alcohol, the alcohol disappears. So in both cases, the alcohol is gone. But explain how these processes are different, even though they can appear the same. So it's very important at this point not to just go on and look at the answer and not just to think through the answer in your head, but actually to pause your recording and take a few minutes to write your answer down. So hopefully you've had a few minutes to work on this problem by pausing your recording. So how are these processes different, even though they appear to be the same? Boiling alcohol is a physical change that should say converts, not convests, that converts the alcohol in the liquid state to vapor. Burning the alcohol is a chemical change that creates a completely new substance. So one is a physical change, one is a chemical change. For this next exercise, classify each of the following as either a physical or a chemical property. So go ahead and pause your recording. It's important to take a few minutes to work on each one of these problems. A marshmallow gets black when roasting it in a campfire. So has the marshmallow changed into something that can change back, or has it been permanently changed into a new substance? Zinc is a solid at room temperature. Is this a physical or a chemical property? And when rubbing alcohol is rubbed on your skin, it evaporates. Is this a physical or a chemical property? Well, this first one is chemical, because once a marshmallow is burned, it is turned into a new substance. And one way to think about this is you can't turn the marshmallow back into what it started from. Zinc, being solid at room temperature, is something you can observe without changing it into a new substance. And the evaporation of a substance, converting from the liquid to the gas state, is a physical property. And finally, classify each of the following as a physical or a chemical change. Are these processes changing the substance into a completely different substance? Or is the substance the same after each of these processes? So the only one here that's a chemical change is the burning of the wood. All the other changes are physical. The rock salt is smaller. The sugar dissolving in water, you're able to evaporate this water and recover the sugar. So no chemical change took place here. And melting a popsicle, you're able to refreeze that popsicle and recover it. So again, no chemical change took place. Here's just some flow charts for the stuff that we've covered. If you like flow charts, you definitely want to use them. If you don't find flow charts helpful, you probably don't want to use these. But some students really like having the material presented in more than one way. Here's a flow chart for chemical, both properties and change. Physical, both properties and change. And here's just both flow charts on one slide. So you can compare them to each other. One thing I want to point out, there are other properties besides physical and chemical, right? When you take something into your body, it can have physiological properties. You can have biological properties out in the ecosystems. You can have toxicological properties. There's many, many, many more properties besides physical and chemical. These are just two that we're looking at in this particular class. There are two really good Quizlets. You can go straight to them if you click on these links, or you can go to the Chapter 1 module. Quizlets are really good ways to practice chemical and physical properties and chemical and physical change. And these were made for me by students. So, that is the end of section 1.4.